Good afternoon, everybody. It's 5 o'clock on Tuesday, which means it's time for math. My name is Jeremy Jasper with KathleenJasper.com. And for the next hour, we're going to do all things math for your certification exams. Just like we do every Tuesday from 5 to 6 p.m. Eastern, I'll be going over a set of problems that I've been gathering throughout the week. You've sent in, I've picked and choose and was able to go ahead and put together a set of 10 problems so that we can go over a couple tips, tricks, all the things that you'll need to do your best and perform your best on your teacher certification exam. As you know, we go live on Facebook and YouTube for every Tuesday. On our Facebook and on our YouTube channel underneath, you will see the 10 problems that we're going through this session. If you didn't have a chance to download them, go ahead and do so now if you'd like. If you're watching live, you can follow along with me, or you can pull the problems up on your own. Or if you're watching on recording, which this will be recorded, go ahead and pause it, download them, and you will have the problems. So I am on YouTube. So any comments that you have while you're watching live, go ahead, send them in. And if you're just watching it for the first time, send them in as well. That way we can go ahead and answer them for you. And also on the Facebook, go ahead, any comments in the comment section below. Whatever I can do to help you out while we go through this session, I am more than happy to do so. So as with every session, I tell you in the beginning, remember you're taking these tests on a computer. So if you have those problems in front of you, you're working out of a workbook, whatever it may be, make sure you have a set or a piece of scratch paper, because that's the only thing that you're allowed to do your work on. Remember, taking this in an exam setting, you're not allowed to write underneath problems. You're not allowed to mark up the problem. You're not allowed to do anything because you're not given it in physical form. You're given it on a computer screen. So any work that you do is going to be done on scratch paper. And so I need you to practice that, because believe it or not, it will save you time during the test. It will make you more efficient instead of just going in it for the first time and not realizing, hey, I can't write on this problem like I used to when I was practicing out of my workbook, because that's just not how it's going to be. So I want you to prepare for that. Also, make sure you have the calculator available that you're going to be using for your exam. Go ahead and look up whatever test you're taking. It will give you the calculator that you're allowed to use. If not, if it's like on the computer screen, more often than not, it's just a 4-function calculator. But they offer tutorials, they offer emulators online that you can practice. Know how to use your calculator. The calculator is your tool. I use the calculator a lot, and I show you how to use it a lot, to where you just do most of the work on a calculator. You don't even write anything down, and then put your answers in from there. So it looks like everybody's getting settled, and we're going to go ahead and start. But before I do, I just want to go ahead and highlight. I'll do this at the end, and I'm going to do it right now as well. This is Thanksgiving week. You know, all of you may be on break and you don't want to deal with anything certification wise. And I totally get that 100%. But for those of you that are taking advantage of this week without having any school, and you want to go ahead and work on your certifications, know that we are having our big Black Friday sale. It's one of only 2 sales that we do throughout the entire year. Black Friday, and then we do one kind of like 4th of July. We kind of spread it out. So we have like 2 sales kind of equidistant from each other in the year. But this is the only time you'll ever see any of our products reduced this low. And it's your best opportunity to get anything that we offer at half price. So from Friday till Sunday, and then that's it. So if you're on the fence, you're not sure, take this opportunity to go ahead and purchase your stuff this Black Friday through the weekend, and any product that we offer on our website, 50% off. And that website looks just like this right here. Just go to KathleenJasper.com. You will see we offer so many programs, mostly in the praxis side, and anything from digital courses to physical books to digital books. We run the gamut. And so if you need something from us pertaining to any of these tests, please go ahead and purchase those on our Black Friday sale. Okay, let's get to the math because that's what you're here for. All right, I do have to circle back on this first problem because this is from last week and I made an error and it's totally on me. I take full responsibility. Sometimes I just go through these and I don't think about them, and it's the same thing that we do during the test. For whatever reason, it just, you kind of go through the motions and you think you're doing something right and it just flies right by. So I own this one. I did this last week and I got an email about it because I went over it and it's my bad. So I'm going to go over it again and we'll make sure we get the right answer taken care of. So what we have is the problem: 32 students in a 10th grade class, 15 of those students on the basketball team and 23 in the drama class. Which diagram correctly shows the number of students on the basketball team, in the drama class, and in both of these activities? So there are 32 students. That means we can't have, more than 32. So if we look, okay, the number one driver in this is all of these numbers here have to add up to 32, right? Because we can't have more than 32, okay? So that's number one. That's where I should have started last week and I didn't, and it snowballed from there. So if we have 15 on the basketball team and 23 in the drama class, so if I do 15 plus 23, we will get 38. But I already told you we got 32 students. So why do I have more students in my two classes than I do in the 10th grade? It doesn't make sense, right? Well, what is that? That represents our overlapping. That means there are some students that are actually on both the basketball team and the drama class. So when you add these two up, you get 38. But if I can only have 32, we'll subtract 32 and we get 6. So 6 represents our number of students that are in both activities. So with a Venn diagram, you see it's got basketball on the left, drama on the right. So that means anything in only those circles are those students that are only in those activities. But you've got this middle overlapping. And why does it overlap? Because it shows that they're in both, right? That's the whole point of a Venn diagram. So that means we have to have our 6 students that are in both activities in that middle part of the Venn diagram. Well, you can see that we've got it in this one and this one. No go here and no go here. So C and D are out, okay? Then the next thing to do is notice that we can't have more than that 32. That's the whole goal of this. Well, if we have 15 and 23, that's what they have here. So I know 15 and 23 are there, but we already established that these numbers represent all the kids, even those that are sharing both activities. So what we do is we take 6 away, because it's the 6 that share it, 6 away from each number. So you would do for the basketball 15 minus 6, and that gives you 9. And then you would do 23 minus 6, and that gives you 17. And that's how you come up with these numbers here in the basketball and in the drama, because we have to take those 6 away. Because again, if we do 9 plus 6 plus 17, we end up with our 32, and that checks out when we go to what we have originally. Okay, so B was the correct answer on that one. I do apologize if you did get confused from last week, but sometimes that happens. It's just what it is. I take full responsibility for that. And now we know what we're doing and we'll move on. Okay. All right. I got a bunch of questions this week that are more upper level math. So I know there have been a lot of inquiries about that. We've had people email and so on. So this is going to be geared more towards that. But again, it's still good for those of you that are taking a general type of test or Praxis Core type of test. because you will see properties of what I'm about to go over on your exam. And so let's start with this one. And a lot of the times you'll see these on pretty standard exams, and you know, it looks a lot more challenging than it really is. And a lot of these tests, and I tell you over and over again, it's all about the perception. You know, we look at things a lot differently in math because we can write them in different forms and variations, but they all say the same thing. They all mean the same thing. They all equal the same thing. So when we deal with this, it says which equation is true for all x is greater than 0 and y is greater than 0. So a lot of times someone comes across this problem, they look at it, they see all these roots or all these radicals, and it's just overwhelming. And even when you first read it, you'll see this right here. First, let me go over this. Don't let this kind of stuff overwhelm you. We have to, in math, set limits and rules. And what they have to do is when they put x is greater than 0, y is 0, if any of these x or y were equal to 0, we would get some undefined answers, and it goes down a weird math wormhole. And it's kind of like semantics, where it's there and it means something, but in the grand scheme of things for this test, it doesn't matter to you, okay? But it has to be there. It's kind of like math law. If you were in my high school math class, then yes, I would make you understand this and do this. But for the purposes of these tests, don't worry about it, okay? Just go straight to the problem and just know we're looking for one that makes the equation true. So the way I want to do this is look at it in terms of a power or an exponent, because the way that they have this with the roots, you can get very confused, because I've got in this first one here, I've got the fourth root. That's what this is. The fourth root of x plus y, and then it's squared. And then I've got equals the eighth root of x plus y. Well, we can write radicals in different forms, and that's what they're trying to get you to do for a problem like this. And we write radicals, we can do them in exponential form, and radicals are always fractional exponents, okay? And so the way that this is actually written is, I'll do this as in the parentheses, we have x plus y, and x plus y is to the, and I want to keep it in this here, is to the 1/4 power. A root or a fourth root is the same as, like if this were x, is the same as x to the 1/4 power. If you're seeing these types of problems, if you're sending me these types of problems, if you notice these types of problems on practice tests that you're taking, then you should know this. You should know that your fourth root or your fourth radical is really to the 1/4 power. Whenever for whatever reason, when I taught exponents and going to radicals, for whatever reason, I would just say that this just fell over. And when it fell over, the base was here, and it fell over into underneath the radical. For whatever reason, the kids got it. It's like a tree tipping over, whatever you can think of it, whatever some other math teacher has taught you. But if you are seeing this problem and you're the person that sent in this problem, and most likely other people are seeing these types of problems, you need to know how to switch from radical form to fractional exponent form, because it's going to make your life so much easier, especially for a problem like this, okay? And we just need to understand our properties of exponents. So what this is x plus 4 to the 1/4 power. And then, and I kept this in the parentheses just because I don't want the x. If I did this, and again, this may confuse people too. If I did it like that, that looks like x plus y to the 1/4 power. And that is not what this is. So that's why we do use parentheses, and parentheses do serve a purpose. And then on the outside here, there's that square. So I can just set another set of parentheses, and then it's to the second power, okay? And then it's telling me that it's x plus y, just like that, to the 8th power. So do these match up? Well, what do we do here? This is an exponent to an exponent. What do we do with exponents to exponents? We multiply them. So it's just like saying x plus y to the 1/4 times 2/1, which is the same as 2/4, which is the same as 1/2. So this is x plus y to the 1/2 power equals x plus y to the 8th power. I'm sorry. Scratch that because I went too fast. And I did exactly what I didn't want to do. 1/8. 1/8. Sorry about that. So do those equal? Do those match up? No, they don't. We have the x plus y, same base, but we have different radicals. And the mistake that people make is, oh, well, if this is to the 4th power and I know I'm taking it to the 2nd power, well, the same thing, you know, exponents to another exponent, just like we did here, you multiply. So 4 times 2 has got to be 8. And so that's why they put the 8 there to kind of confuse you. Okay. And sometimes they did do a good job on that. So that's where we need to know our properties of exponents and how they work out. So A is not going to work out for us. Okay. And I am showing you all the steps, but for the most part, you do need to shorten your steps. So if this is the first time you're seeing these problems and they're new to you, then probably Google search these problems and get more, and then just start getting in the habit of doing them and shortening your steps and using as little writing as possible, because it's all about time and efficiency. So A is out because that doesn't work out. Now the next one, same thing. If I do x 4th root, that really means x to the 1/4 power plus x to the 1/4 power. Okay. Plus, okay, equals, and then these are x plus y, and then to the 1/4 power. Oh, I'm sorry. I did this last time. That's a y. All right. So what do we know about this? This is x 1/4, y 1/4. Can you add these two together? The only way we can add these two together is if they have the same bases. This is a base x, this is a base y. This is in simplified form here. If this were x to the 1/4 plus x to the 1/4, then we would have 2x to the 1/4. Does that make sense? Because they're both same bases. But that does not happen up here because one is x and one is y. They want you to think that you can just put this together in the parentheses and have them both to the 1/4 power. And that is not correct. Okay. Because this is adding these. You can't distribute the 1/4 like that in here and make it equal. That's not the way that this works when we're dealing with these radical or these fractional exponents. So B is out of the question. Okay. Then the next one, this is now x to the 1/4 times x to the 1/4 equals x, okay, or square root x, sorry. So now when we have multiplication of exponents, these are the same base, which is good. What do we do when we have same base and their exponents? Well, you keep the base the same and then you add the exponents. It should be 1/4 plus 1/4, which is equal to 2/4, which is equal to 1/2. So this is equal to x 1/2. And what is this? So if you don't know, then you should know if you're doing problems like this. We see that we put 4s here, that's the 4th root, 8 here, that's the 8th root. When there's nothing there, what is it? This is the most common one, and we don't put it there because it's something that's never done. but a square root is a 2, right? Because square means multiply it by itself. What these roots are, it means what number times itself 4 times, that's what this 4 is here for, will give me the value inside of here. And then the same thing here, what number times itself 8 times will give me the value in here. That's what these 8th roots, 4th roots are, cubed roots, all that kind of stuff. So this is a square root. What number will give itself twice? And so if this is a 2, then that means a square root as a fractional exponent is x to the 1/2 power. Does x to the 1/2 equal x to the 1/2? Sure it does. That is where the answer is. Okay, so knowing our fractional exponents. Let me do the last one just because this is kind of a lesson on dealing with what to do with exponents. And we knew that we multiplied these, so we add the exponents. The next one we're dividing. So if I could, this is y to the 1/8 over y to the 1/4 equals, and then it's the square root, so it's y to the 1/2. When we are dividing by exponents, same base, so we're y and y, we subtract the exponents. So this is y 1/8 minus 1/4. Now you notice that 1/8 is smaller than 1/4, so it's going to be a negative number. When we go ahead and we do this, if we make it 8, it's going to be 2/8. So that's going to equal y negative 1/8. Okay. And then if we drop this down here, y equals 1/2. It does not. And so that's why D is also incorrect. Okay. Multiplication of exponents, you add the exponent. Division of exponents, you subtract the exponents. And just knowing what your radicals do in exponential form. Okay. The next one, which expression is equivalent to 2 to the 2x plus 1 power times 8 to the 2nd power? So again, we have to understand our rules for exponents. As I rewrite this, I'll get rid of the parentheses here. So it's 2 and then 2x plus 1. And then this is 8 to the 2nd power. When we're dealing with exponents, the only way we can manipulate them is by doing what? Having same bases. So as we look at this, and this goes for all these tests, they're not going to try and trick you. They're not, although it may feel that way. This is a giveaway for most of these problems. They just want to know, do you know what you're doing? And can you handle, what they're trying to throw at you with these bases and these exponents? See this 2 here. See if we can deal with 8 and get it down to a base 2, which means, can we multiply 2 multiple times and get 8? And you can't, because 2 times 2 is 4, times 2 again is 8. This is the same as saying 2 to the 3rd power. So I can change this 8, okay? And again, this is what I'm talking about when we do different variations of the same thing, learning how to see things differently. And they're going to give you this stuff, because if they just put 2 there, it'd be too easy, okay? So this now changes to 2x plus 1. And then remember, 8 is the same as 2 cubed, or 2 to the 3rd power. And then I'll just put the dot here so we know, but it was the parentheses next to each other, still means multiplication. This is 2 to the 3rd power. And don't forget, this 2 was there too. So if that was there, then that means we're just going to multiply that. So this becomes, I'm going to rewrite it here. I'm going to erase this top part. And I know I'm trying to go the long way so I can kind of explain step by step how this comes into fruition, but you should, after practice, recognize when they throw at you base 8 and base 2, you should know right away, aha, 8's really 2 to the 3rd power. And so that should be our, so you should start the problem as writing it out to 2x plus 1. You should write it out like this in the beginning, okay? And that takes time and practice. And that's what I'm talking about when you shorten your steps so that you don't have to write as much and you allow yourself as much time as possible to answer the problems on these tests. Okay, let me clean this up here. So this becomes 2 to the 2x plus 1, and then 2 to the third power times the second power. So I have 2x plus 1, 2 times to the sixth power. We now have same bases. Once I have same bases and I know that it's multiplication, what do? We add our exponents. So when I add these together, like terms go together, there's a 2x. I can't do anything else with the x. So I have base 2, and then I have 2x, and then 1 plus 6 equals 7. So my answer is now 2 to the 2x plus 7. A is the correct answer. Okay. You're going to want to look at these and say, oh, they, that's how they work out. 8 should go with 2 and I get 16. So I would be here and here. And then 2 and 2x should give me 4x, and 2 and 2 should give me 2. And then a lot of people would pick this one here. That is not how it works because we're dealing with exponents. Okay. And it's totally different. So you have to be aware of that. All right. So properties of exponents, make sure you know them, make sure you're familiar with them. If this is a type of problem that you've seen in any of your practice tests or your workbooks or study materials. Okay. This is a good problem because a lot of these are logic problems and you still have to have an understanding of the math and then specifically the terms that they're giving you. It says two whole numbers, A and B, have a least common multiple of 180 and a greatest common factor of 12. Which value could be the sum of A and B? So they tell you we have two numbers. Once you get these two numbers, so first, least common multiple. What is least common multiple? When you think least common multiple, I want you to think fractions, right? What, especially adding fractions, what's the one thing you have to do to add fractions? And we call it a common denominator. Least common multiple is your common denominator. So I'll put LCM, excuse me, because in order for you to have your fractions simplified and you're adding or subtracting, you have to have the least common multiple, which means whatever two numbers they give you, and in this case, there's going to be two different numbers, it's the lowest possible number when the lowest, how do I write this? When you multiply those numbers, it's the lowest factorial number for them, okay? But just think least common multiple is your common denominator, okay? And then greatest common factor of 12. That means whatever these numbers are, 12 is their largest factor. That means the number that you multiply 12 by another number, 12 times something, and you're going to get these two numbers. Okay, so let's kind of go through it so you have a better understanding what I'm talking about, because if I don't show you, it's not going to make a lot of sense. So the best way to do this is to understand our multiple is 180. So we need to figure out how do we make 180. And this is where you need to either go to your calculator or understand, your times tables and all that. But, you just kind of think of this as 18. So the way I'm going to do it, I'm just going to run it right down. So I know 2 times 90 gives me 180. 3 times 60 gives me 180. 4 and 45. I've got 5 and 36, and then 6 and 30, and 9 and 20. So now once I get down to here, look at what I'm focusing on. all of these, so these are factors, okay? So when we talk about factors, we're talking about, sorry, what they're asking here, greatest common factor. So it's going to be a part of these numbers, our greatest common factor, and specifically 12. So the reason why I only went to here, and I know that there are more, is because this set of numbers here, 90 is the greatest number you're going to have for a factor. 90 is the greatest number you're going to have as a factor. And these numbers in particular have to be divisible by 12. So if I went down one more, right, I could do 10 and 18, but that doesn't matter because none of those are divisible by 12. And if I keep going, it's pointless. So what I want to do is I want to look at these numbers and I want to say which ones have 12 as a factor. Let me erase this. And as I go down, 90 is divisible by 12. 6 is divisible. I'm sorry, 6. 60 is divisible by 12, right? Because if I do 60 divided by 12, I get 5 and 12. And does 12 happen to be the greatest common factor? Well, it's 5 and 12. You can't go any higher than 12 and get 60, right? I can't do like 15 times a number and get 60. It doesn't work out. So, or 15. Hold on one second. Oh. Okay, hold on one second. Let me go through this again. 12. Oh, it might be. You know what? I think I might have because I saw when I did this, I went down and I saw 60 and 36 right away. So that's what I circled. And so same thing with, you know what? Any greatest common factor? Because that's 5 and 12. That's 3 and 12. You know what? And here we go. Sometimes on the fly, I gotta see because I know 10, 12. Because 12 and 15, right? So we got 12 and 15. You know what? I may have to. Let me see here. This is real time here. This is why we got to figure these things out. So if I have at least common multiple of 180, okay, greatest common factor. So I don't know where they're getting this greatest common factor of 12, but this is the rest at 12. And then those would be all of our factors of 180. 12 could be a greatest common factor. Well, 12 and 1. So that would work, but there is no other one that we could use because 18 times 2 is 36. So let me think this out here. We know that they have to have least common multiple of 180. And what that means is if I have 60, and that's what I'm talking about with the fractions. So here was my 12s. And if I did, let's say I had 160 and 136, then that means the least common multiple. So if I did 60 times 36, because you know how if you get a fraction, you got let's say I had to add these. Well, a go-to is always multiply them because you know that if you multiply them, obviously they're two common factors, they'll create a multiple. And so like in this one, it'd be 2160 and 2160, right? And you would do the whole thing. But when they ask in this question here, I have, remember 180 is my least common. So if I did 180 here and 180 here, right, then that is their least common multiple. I can't do a number less than 180 because they won't be divisible by that. Does that make sense? Because if you did 60, 60 would be 120, and 120 divided by 36, that doesn't work out. So 180 is their least common multiple. That's why now that I look at this with a greatest common factor of 12, that's why I picked these two, because they have 12 as common factors. Okay. But that's not their greatest common factor, because 16 can go 15 and 36 can go 18. And so if I found these, which value could be, okay, maybe this is Y, and we have to look out for this. C could be, and maybe that's where I'm picking up on this, because it said it's not for sure, and it said could. And again, I try to show you a lot of these problems. I pull a lot of these problems with the could be's, because it's not definitive, because the way that they're asking it with a common factor of 12. So 60 and 30 would be my A and B. At least that's what I'm going to pick. And if I do pick that, then remember, they want the sum. And so again, this is a multi-layered problem, and that's why I picked these problems as well. That's the main reason why I picked this problem, is because it tells you, okay, you got to do all this stuff, but the actual question is, what is the sum of both numbers? So you went through and you found these numbers. We found these numbers, let me erase this, 60 and 36. So that when I add them, 60 plus 36, that equals 96. And that is my answer right there. So that's the available answer choices that I have to deal with. If I had any other option, they have to have a common multiple of 180 and a greatest common factor of 12. The two whole numbers. If you look, I don't think I can pick any other numbers that have 12 as a greatest common factor. I guess I could choose 12. Okay, let me see. Let's do 12 plus 60. And let's do 12 plus 36. That gives me 72. This gives me 48 with the options that I'm given. And that's where I'm going with this problem for now. Again, somebody sent me this problem, so I'm only doing it how that was sent, and I didn't get answer explanations for this. So these could be possible answers as well, but because the answer choices only give me a certain amount, you see that 72 and 48 don't work, but in this case, 96 works for these. And these are the only three numbers that have 12 as a common factor. And so therefore, that's my explanation on that. Hopefully that's right. And if you sent this to me and you can send me the explanation, that would be great. Otherwise, I'll see if I can figure that out. But this makes the most sense to me until I just read it now, because I went over it everything last night and it just hit me where it said the greatest common factor, and I got down to that 12 and 15 and I got to that 18. So hopefully that's correct. Bear with me on that, and it seems good to me. So all right, next one here. It says the graph of y equals ax plus b intersects the graph of 2x minus 8y equals 4 at -2, -1. Given that the two lines are perpendicular, what is the value of a plus b? So we do have a lot going on in these two sentences, and it deals with equations of a line and then perpendicular. And again, the ultimate question is, what is the value of a plus b? So it's those multi-layered problems. A, they're telling us, you're used to this. You're used to y equals mx plus b. It's the same thing. They're just giving us A and B. That's all. It's the same exact formula. Sometimes they do switch it up depending on the test that you're taking, depending on the state that you're in. But do know it is the same as y equals mx plus b. They're giving us the y-intercept form or slope-intercept form of this problem. Okay. They just want to know what's in this spot, what is in this spot, and what is in this spot. All right. So what we want to do is understand we're given our slope, intercept, and then we're given this line. We know that they intersect at some point in that point. So, and they're perpendicular. So it means that 90 degrees, they intersect at some point, this point being -2, 1. And they want to know what's the value of A and B. Okay, so I've got, let's just say this is 2x. It's not, but this is 2x minus 8y equals 4. This is y equals mx plus b, or ax plus b. We need to know how to figure out the equation of this other line. So how do we go about doing that? And it's pretty straightforward. So what we want to do is we'll start with our y equals ax plus b. If it intersects at this point here, okay, we know that we can use this as our x and our y. So I can now create the equation, and I'm going to do it over, where am I? I'm going to do it over here. I know that I have -1 is equal to a times my -2 plus b. So I can't figure anything out yet because I have one equation that has two different variables, and I got to get that down to one variable. So how am I going to get that down to one variable? And the way I'm going to do that is knowing that this represents slope. So if this represents slope, I can take whatever the slope is on this one. And remember, slope is always the number attached to the x. And then understand that it's perpendicular to this line here. So I'll go about that right now. We need to simplify this because this is in standard form. So we do 2x minus 8y equals 4. Whenever I need to find the slope, because I only need to find the slope for this line. So if I need to find the slope, this 4 right here becomes irrelevant. I don't need to know that's ultimately it's going to be the y-intercept. So I don't need to know that. So I'm going to go ahead and just get rid of it, because the less I have to look at, the less opportunity to make a mistake. So I need to subtract the 2x because I have to bring it to this side. Crossing that out, I get -8y is equal to -2x. And that's important because that's what I need as my slope. And then we need to simplify. You can never have anything in front of the y. So we're going to divide by -8, divide by -8. Negatives cancel. I have 2 over 8, which is the same as 1/4 x. So this is like y equals 1/4 x. This right here, the 1/4, that's all I need. Okay, actually, you don't need the x. The x is. This is the slope. All right, that is the slope of that line. And so now, if this is the line here and the other one, or each line is perpendicular, what is perpendicular slope? Perpendicular is opposite reciprocal. Okay, so what is opposite reciprocal? Opposite means it's the opposite sign. So in this case, I have, just over here, I have 1/4. So opposite is going to be negative, right? Because this is positive, opposite is negative. If this were negative, opposite would be positive. And then reciprocal means flip the fraction. So 1/4 goes to 4 over 1, or just 4. So this is the slope that needs to be inserted into this equation here. Does that make sense? Because both lines have to be perpendicular to each other. If we know the slope of this one, that's this one right here, is 1/4, that means the other line, which is this that they're talking about, has to be the opposite reciprocal. Okay. Some people will read this problem and say there's not enough information to find the problem. And that's what they want you to think, and then get confused and start doing all sorts of weird things. But that's not the case. You just understand I got to find the slope and then make it reciprocal and then insert it into the other equation. So when we do that, so if I can make some room here, this is now -4. This now becomes, let me erase that. This now becomes -4, okay? So now we can solve for B, okay? Remember, they want to know the value A plus B. Well, you found that this is -4. Well, -4 was A. So I've got 1/2. Now I got to find B. In order to find B, we just solve for it. So I have -1 is equal to -4, -2 gives me +8 plus B. Subtract the 8, I get -9 is equal to B. So once I know that, that's this right here, -9. It's asking me the sum of A and B. So when we do that, don't have a lot of room, but -4 plus -9 equals, I don't like that 4. Quick math you can do in your head or your calculator. -4 plus -9 gives me -13. That is the correct answer for what they're looking for. Lots of layers in this problem. And, I stepped it out the right way that you should do it, finding the slope of this equation that making it reciprocal, inputting everything else in there, and then understanding that it's A plus B. It's your slope plus your your y-intercept for this unknown equation. I know it's a mouthful, but that's how you do it. Everybody that takes math tests, general math, core math, anything, you do need to know how to manipulate slope-intercept form. Know your slope, know how to find it, know how to do parallel slope and perpendicular slope. So please, if this is something that you haven't seen or you're rusty on, go ahead and get some practice problem. Get used to changing around your standard form, that's this right here, into y-intercept form. All right. Okay, moving right along. A couple other problems that were sent in to me, and these are kind of, I could see these as being general types of problems, but they come across confusing just because of the way that the answers are. And so for this one right here, it says the following list shows the first 6 terms of a sequence. We got 1, 1, 2, 3, 5, 8. Which of the following formulas can be used to find the terms of the sequence? And we see that our answer choices say A sub 1 equals 1, A sub n equals A sub n minus 1 for all n's greater than or equal to 2. It's like, okay, so what are they talking about here? And then the next one, A sub 1 equals 1, and then A sub n equals A sub n minus 1 plus 1 for all n is greater than 2. And then we have A sub 1 is 1, A sub 2 is 1, A sub n equals A sub n minus 2 plus A sub n minus 1, all for n is greater than or equal to 3. And it looks like a lot of gibberish. So let's go ahead and let's find our pattern, because they tell us it's a sequence. So if we know that it's a sequence, there's a pattern involved. So with this pattern, we have 1 to 1. So if I go 1 to 1, can I add it, multiply it, subtract something, powers, do whatever? And there's not a lot of information there, because from 1 to 1, we can do another thing. But then it jumps from 1 to 2. So how do I get from this 1 to 2? Well, I can do 1 plus 1. I can't do 1. I can do 1 times 2 equals 2. Okay, so that's 2 different ways. But then how do I get from 2 to 3? I can't do 1 times 2 doesn't equal 3. 2 times 2 doesn't work. 2 plus 2, no. 1 plus 2 equals 3. Okay, so let's go back. And if sometimes you just kind of see it, sometimes you just kind of work through it. But I kind of saw it right away. I go 1 plus 1 equals 2. So then if we back up, and then 1 plus 2 equals 3, and then 2 plus 3 equals 5, and then go back one step, 3 plus 5 equals 8, and then the next one would be 5 plus 8 equals 13, And then you would do 8 plus 13 equals 21. Okay, you get the pattern there? So hopefully, number one, you recognize the pattern. So it's the previous two numbers give you the third number. So 1 plus 1 equals 2. Then go back. 1 plus 2 equals 3. So previous 2 gives me the third. So these two give me the third. These two give me the third. Okay. So when we look at this, just kind of, I'll try and explain this as best I can, as quick I can. A sub 1, anytime we have this sub 1, that means the first number, okay, in the sequence. So that means this right here. A sub 1 is 1. So then when it says A sub n means whichever one. So if I want the fourth, so if I said A sub 4 is 1, 2, 3, 4. So that would be a 3. So then that means, so A sub 4, that means that should equal 3. So A and then n minus 1. So if I got 4, that'd be 4 minus 1, which is 3. So that would be the third digit. That would be 2. So then 2 would equal 3, and that doesn't work out. Okay, does that make sense? Kinda. It's just telling you which number in the sequence to take. All right. So then basically this says you take whatever number, subtract it from the one before, and that would get the number. And that doesn't make sense. Like the previous number is not the same number. In this case, it is, because you see the 1, right? 1 and 1, the previous number is the right number. But in this case, if I did 2, 2 is not the same as 1, right? Because A sub 1 is 1. So that means 1 equals 1 if it were 1. If it were 2, that means 1 equals 2, and it's a mess. So, and it says greater than 2. So n has to be greater than 2 or equal to 2. If it's 1, it doesn't work out, okay? This one says we take the number previous and add 1. Well, it works out here. If we take the number previous, 1 and 1, and we get 2, that works out. And then 2 and 3 plus 1. But then when we get to 5, it doesn't work out. So no go. This one makes more sense, because remember I said the previous 2 give you the third. So if I'm giving you, and they give you this, A sub 1 and A sub 2, because these numbers are the same, that's what's throwing everything off. You can't make a pattern off of it if we start from 1 and then just say, oh, multiply each one by 2 or add the previous. It doesn't work out that way because you have the double ones. Double ones throw everything off, which is why A and B don't work. The double ones here, they're telling you A sub 1 is always 1, A sub 2 is always A sub 2 is always 1. But then it says n has to be greater than or equal to 3 for all n's greater than. That means they're starting with this third number here. And that's why they give you the 1 and the 1, because that way when we start with the third number, okay, then that means we do 2 plus 1, right? This is going to be 2 plus 1, and then it's going to be 3. That's this number here, right? So I know it's confusing. I know it's not easy to explain. And I know a lot of people don't get these types of problems on their exams, and it's not standard form for patterns. Like there's the n and then n minus, or the a, you know, n subs, whatever, and powers and all that stuff. But this is just specifically for this sequence here. So just understanding that, know that, remember we did the previous 2, 1 plus 1 is 2. So we always have to add 2 numbers. These don't always add 2 numbers. This one doesn't add 2 numbers. Okay. And this one only adds 1. It's the number plus 1. And we can't go plus 1 because 3 plus 1 is not 5, it's 4. 5 plus 1 is not 8, it's 6. So this is the only one that makes sense. Try and find the ones that make the most logical sense. That's my best explanation there. Sorry if it was long-winded and confusing. Okay, let's keep this thing rolling, as I want to try and get everything done here pretty quickly. All right, this next one, we've got 3 conversions. 1 tablespoon is a 1/16 of a cup. 1 teaspoon is 1/3 of a tablespoon. 1 ounce is 2 tablespoons. Each of the preceding conversions shows equivalent measurements. Based on the equivalent measurements, which of the following quantities is greatest? So the best way to do this is we're going to have to do conversions, obviously, but you always want to get down to the smallest unit of measurement. And the reason why we want to get down to the smallest unit of measurement is because it avoids fractions and decimals at all costs. I can't guarantee it, but it makes it easier to deal with. Because if we went everything into cups, a lot of these are smaller than cups, you're going to get fractions and decimals, and it's going to mess with you. So let's go through. We're going to start with the first answer choice, and we'll start with 12. So I know that there are 12 tablespoons. So the way we're going to convert this, and I'll start at the top because we need room for this. I have 12 TBSP, so 12 tablespoons. And the way that I'll show you this conversion here is we're always multiplying. So we have to get rid of tablespoons and we got to get to teaspoons. And if we look here, our conversion for teaspoon and tablespoon is right here. So it's 1/3. So that means I have one tablespoon. Let me do this. 1 tablespoon. So you see how I got them on the top and the bottom. 1 tablespoon. Oh, I'm sorry. I gotta remember, these are weird ones. They give these to us in this problem like this. Some of you will have formula sheets, some of you won't, but if you don't, then this is what we have to deal with. It's 1/3 tablespoon is equivalent to 1 teaspoon. Okay. So what happens is tablespoons cancel out because if it's on top of, imagine us, we're dividing these. If you divide the same thing, you get 1 or they cancel out. So now all I do is this is equal to 12 over 1/3. And you know, if we're dividing by a fraction, we flip that fraction up, it's 3 over 1 or multiply, or you can do it in your calculator, but we end up getting 36 teaspoons. So 12 tablespoons is equivalent to 36 teaspoons. The next one is 7/8 of a cup. So I do 7/8 of a cup over 1. And then our conversion for cup is going to be this one right here. So I got to go to I got to go to teaspoons because I want to make all of them teaspoons. So if I do it like that, then we go 1 cup, 1/16 of a cup is equivalent to 1 tablespoon. And then 1/3 tablespoon is equivalent to 1 teaspoon, right? That was from our other conversion. And then when we do that, we end up getting, it's 7/8 over, I think it was, 1/48. Again, do it in your calculator or just some quick math, flip the fractions and multiply them, and you get 42 teaspoons, okay? So we know that 12 tablespoons is out because 42 is greater than 36. C gives us 8 fluid ounces. So then we have 8 ounces, and our our conversion is now going to be this one right here. So I know that 1 ounce is the same as 2 tablespoons. And then again, do the same thing. I know that 1/3 tablespoon is equivalent to 1 teaspoon. And then, and I should have done this here because cups cancel, tablespoon, tablespoon leaves me with teaspoon. And then ounces, ounces, tablespoon, tablespoon. I know I'm in the right spot because I get teaspoon. And this one comes out to 16 over 1/3. And if we do 16 over 1/3, we get 48 teaspoons. So then that knocks out our 7/8 cup. This is 45. It's already in teaspoons. I know 48 is greater than 45. C is the correct answer. Okay. maybe it's a little long, but given these, because I don't want to do a different conversion because I don't know if you're going to get a formula sheet. And this problem was sent in to me by somebody. So it must have been something that they've seen in their study guide. So using what they have, this is the best possible way, in my opinion, to keep everything straight and orderly. You know, if you do it fast enough, you do have enough time. You can kind of skip a couple steps here and there, but I did want to write everything out so that you could see it. You don't necessarily, you know, have to put TBSP, or you can put big T, small t, you know, all these little things that you can do. But the biggest thing is to practice doing these conversions. And if you're going to get a test that makes you do multiple conversions, then you need to be comfortable with this. All right. Next one here. These are always killers. And for the most part, they're not that difficult. It's just a lot of stuff on the screen. And when you see a lot of stuff on the screen, you think difficult, too much time. I don't think I'm going to be able to get through it. You know, all these things jump in your mind. So we see that the following table is the cost of membership to Gym G, and we have 5 possible lengths. And then underneath it says Gym H has the same possible membership lengths, and the cost Y in dollars of a membership to Gym H for X months is given in the equation 2Y minus 50X equals 85. And then it says all of our answer choices. So what we have to do is figure out which one of these is true. Did I not put that in the question? Maybe that was, okay. I thought I put that in there, but if you're wondering what the question is, out of A, B, C, and D, which one is correct? Which one is true, all right? And if we look real quick, it says the cost of membership G is greater than the cost of membership H for the lengths of 6 months, but great. Okay, so we need to compare the two. And how are we going to compare the two? One's a chart, one's an equation. Well, we have to make them the same. Can't make a chart out of an equation. I mean, I guess I could, but it's a lot more difficult. I should just do equation versus equation. So let's start with Gym G. And I'm just going to show you real quick how to create an equation given a chart. So we know that y equals mx plus b is our slope intercept. I know that this is in standard form, but I can convert this into slope intercept very easily. So that's what I'm going to do with that one. I'll wait until I get the first one. The key here is to recognize your slope and to recognize a y-intercept. The easiest one is y-intercept first, because y-intercept is going to be 0, comma, y. This 0 is in the x spot, and the y obviously is the y. Whenever you have a chart, pretty much the left is the x and the right is the y. So on a graph, this would be 1, comma, 75. This will be 3, comma, 125, 6, and so on. The goal here is to find out the pattern of the y. As you can see, if I went from 75 to 125, this is a difference of 50, right? But this right here is not consecutive. You have to, in order to get the pattern, you have to be consecutive. In this case, it's months, so I got to go 1 month, 2, 3, 4, 5, 6, all the way up. This goes 1, 3, 6, 12, 24, it jumps there too. So I need to figure out what the difference is between these two. And in order to find the difference of these two here, just think about it. What's between 1 and 3? Well, it's going to be 2. And what's the difference between 75 and 125? Well, it's going to be 100, because with a difference of 50, if I split that up, it's 25 on each side. So I know that in between 1 and 3 is a point 2, comma, 100. And then if I go 3, right, that's the next one, I get 125. So do you see the pattern here? 75 to 100 is 25. 100 to 125 is 25. I've got 4 and 5 in between here. So if I did 4, that means it would be 25 more. So it'd be 150. 5 would be 25 more 175. So you see the pattern? The pattern, okay, in this case, let me erase this. Well, let's see here. They go by 25s. The pattern is 25. So pattern is the same as slope, which is 25. So that means as I'm writing my equation, y equals 25x plus, how do you find your slope intercept? Well, slope intercept, remember, that's the 0. Well, if I have 1 here, what if I just went backwards? What if I subtracted 1? If I subtract 1, I get 0. Well, if I'm subtracting, right, these were adding. 75 and 25 give me 100. 100 plus 25 gives me 125, and so on. So if I subtract 125 from 75, I get 50. So 0, 50 is a point on this graph. I could go back. I can go -1. What's negative? I just take another 25 away. So -1, 25. Does that make sense? So I'm not really concerned about that. I'm concerned about this. That represents my y-intercept because there's my 0 point on my x. So my y-intercept is now, let me get rid of all this. Because I have this point 0, 50, my y-intercept becomes 50. This takes a little bit of getting used to. If you see a graph, you should be able to right away pick it apart, find me the pattern right here. In this case, it's plus 25. And then find me a 0x any way you can. Usually, you know, they'll give you 1, but you know, you can always go backwards. If you can go forward, you can always go backwards, get to that 0. And then that's how you find your slope intercept. Otherwise, you can take these as a point, run them through the equation, then solve the equation for B. There's multiple ways of doing it, but I feel like this way is faster. You practice this way. That means getting to see as many of these graphs as possible and just finding the equation for it. And you'll get it every single time. So the equation for this chart is y equals 25x plus 50. And if you want to double check yourself, pick any point in here. Let's just randomly choose this right here. Let's do 6 and 20. That means if I put in these 2 points, that means if I do 200 as my y equals 25 plus, I'm sorry, not plus, times 6 as my x plus 50, that means that should work out. Well, I know that 25 times 6 is going to give me 150, and then plus another 50 equals 200. Does that work out? Yes, it does. See, that's how it goes. Okay. So now that we took the time to do that, and in the real setting with practice, you're going to find this much quicker, but I feel it's important to really explain it to you so that you can just rip through these charts and just get the equation right away instead of doing more work than is necessary. Next, we need to figure out what this one is. So I've got 2y minus 50. And again, 2y minus 50x equals 85. What I have to do here is, okay, you get all this stuff. Just, I want to make sure we got enough room. You understood all this. That's good. No more. We know we are at y 25x plus 50. Y 25x plus 50. This one is 2y minus 50x equals 85. We need to add the 50x because we got to get it to this side. We're left with 2y gone equals 50x. Always put the x first, plus 85. And then divide by 2. Sorry, I'm just kind of running through this. Cancel that out. That's going to be 25. I'm going to put the answer up here. So we have y equals 25x, and then 85 divided by 2 gives us 42.5. Okay. And then we've solved that. Basically, we just put it from standard form to slope intercept form. And so that was quick. We have G here. We have H here. What do we notice about G and H? Their monthly rate is the same, right? 25x. That just means how much you charge per month. But their fee to start is different. So it costs more for G than it does for H. So as I go through the answer choices now, I've got the cost of membership to Gym G is greater. Okay, Gym G is greater, right? Because it's 25x plus 50. Then the cost of a membership for Gym H for membership lengths of 6 months or less, but is greater for membership lengths of greater than 6 months. Well, it's never going to change. No matter what, you're always paying this $50 versus this $42.50. So whether it's 1 month, 10 month, or 100 month, it's always going to be more because the rate is the same. With 25x as your rate, that's always going to be the same. So it's dependent upon this y-intercept number, this 50 and 42.5. So that's not an answer. The cost of membership Gym H includes the same initial fee. That's not true because the initial fee is 50 versus 42. No good. The cost of a membership Gym H includes a greater initial membership fee than the cost of the membership to, nope, because the initial membership fee is different. The cost of membership G is greater than the cost of membership H for any number of months. G is always going to be greater than H because of 50 greater than 42.5. D is the correct answer. I know that was a long-winded problem, but all you have to do, and because I spent time focusing on this chart, getting the equation from the chart, knock that out first, switch around that one, look to see right away, you got an idea what's going on here. G is always going to be bigger because of what the y-intercept is, and then you can go from there. Okay. Next one. Madeline's Floral Boutique uses a size of vase that will accommodate more than 17, but no more than 25 flowers. Which graph represents the number of flowers in the vase? All right. Looking at this, and the biggest thing here is, what do these mean? I've got open circles and closed circles, and that's the reason why I wanted to do this. This represents less than or greater than. God, that's terrible. Wish they had an easier way to write with this. Less than or greater than. This is less than, equal to, greater than, equal to. That's what you need to know. The empty circle, think of it as a force field. Nothing can touch whatever inside of that. So in this case, if I've got this as a 17, that means it cannot be 17, right? That's what open circles mean. It cannot be the number that it's on. So when they tell us that will accommodate more than, is more than equal to 17. No, it's not. More than 17 is bigger than 7. So it can't be 17. So I need an open circle on 17. So get rid of anything that has a closed circle on 17. Not going to be C, not going to be D. The other one says, but no more than 25. Does no more than 25 mean that it can be 25? Yes, it means that it can be up to 25 and 25, but nothing more than 25. So if it can be 25, that means there's an open, I'm sorry, not open, a closed circle. That's this right here. This is our 25. This is our 17. Okay. So then as we look at the graphs again, anything that's open on 25 is a no-go. So whatever I have left open on 25, oh, E is gone. And now I'm only left with A and B. So as I look at A and B, I am confused because they look exactly the same. Am I looking at this correctly? Oh, I'm sorry. Just kind of glanced over it. I'm just looking at the dots. A says it's not 17 and it says it is 25. You'll see right here. That's what threw me off right here. You gotta be careful with computer tests because sometimes you just don't see it. See the shading? This shading means that it's between. It means it's greater than 17 and less than or equal to 25. That's what this is. 17, it's greater than 17. That's our X, and it's less than or equal to 25. That's what it would look like if you had to write it out. Okay. So that's that. Just knowing the open and closed circle. That's all. And then finally, the last one, always try and throw a stem and leaf in there if I can. We have daily high temperatures in April. Here's our stem and leaf. We got all these values. What does it mean? And then it says, by how many degrees did daily high fluctuate during April? So we have 5, 6, 7, 8. 5, 6, 7, 8 represent 50, 60, 70, 80. And then these numbers here represent each one. So this is really 52, 55, 55, right? If there's two numbers that are the same, you don't not count the same numbers. It's just two of the same number. So that's where you get the 55. When they're asking us for what they're asking us, fluctuate, daily high fluctuate. Fluctuate means from high to low, high to low. Well, just go, what's the lowest number? That's this number here, to the highest number, which is this number here. And that's it. What does fluctuate mean? It means the range. What is the range of these values? High number, low number. This represents 52, and this represents 88. If I were to subtract the two, so I'll do minus 52, I should get 36. And 36 is the correct answer. That's all. Know how to get your values on a stem and leaf. That's the biggest thing. That's the biggest part of that standard, honestly, because they're going to ask you anything from mean, median, mode, range, because ultimately it's a data set. It's just a different way of writing a data set. You know, it's just trying to give it to you in a different form, just like we talked about at the beginning. All right, that's it. That's all we got for tonight. That was longer than I expected, but that's okay. We have fun when we're doing math. Time flies. And so last slide is always the answer key. All right. And if you have any questions whatsoever, please hit us up, info@Kathleen with a K, Jasper.com. Okay. Let me double check. I don't see any comments on the YouTube. Let me check Facebook. I don't think there's anything there. If there is, I'm sorry if I did not get to you. Hold on, please. Okay. Yep, it doesn't look like anything. All of you are on break, and you're not watching math while you're on break. And I totally get that. And I'm cool with that. No big deal. You'll watch this next week and that'll be totally fine. Okay. Once again, I hope everybody's having a great holiday week. Get some rest, get rejuvenated. Next thing you know, it's going to be finals and then winter break. We get to take a breather. Info@KathleenJasper.com, Facebook, KathleenJasper.com, Twitter, Instagram, YouTube, videos, anything you need, please let us know. One more time, if I may, we are having Black Friday, starting Friday, going all the way through Sunday. Anything that we offer on our website is half off. So that's the best deal you're ever going to get from us throughout the year. Half off. Get it now. Load up on things now. Even if you know you're not taking the test right now, but you may be taking it in 6 months or at the end of this year, might as well get it now. That way you have your study materials. You know, access never expires, so you'll be able to access your digital course as long as you need it. And KathleenJasper.com is where you'll get everything that you need. Ask us whatever you need, videos, whatever. All right, that's it for me for tonight. I hope everybody has a great Thanksgiving. Enjoy it with your friends, your family, whomever it may be. I will see you all next Tuesday. Have a fantastic week. Take